Air pollutants are substances in the air that can harm human health and the environment. They come from various sources, mainly as combustion products and industrial waste. Let's take a closer look at each one of them. Gas pollutants include carbon, nitrogen, and sulfur dioxides. The latter two exhibit polarity because of their bent geometry. Carbon dioxide does not have this property, being a non-polar molecule of linear geometry. Next, methane and chloromethane, which are also gaseous pollutants, both have a tetrahedral geometry surrounding a central carbon atom. In methane, the dipole moments cancel out due to its symmetry. However, replacing one hydrogen for a chlorine atom in chloromethane creates an overall dipole, making a polar molecule. Nitrogen dioxide and sulfur dioxide react with water in the atmosphere to form nitric acid and sulfuric acid. These molecules precipitate along with water as acid rain. They exhibit uneven distribution of hydrogens across terminal oxygens, inducing an overall dipole for both. Last to showcase are solid pollutants found in the atmosphere, such as soot and fly ash. Soot is a product of incomplete combustions. It mainly refers to various clumps of impure carbon molecules. Fly ash comprises the particles driven out of coal boilers at power plants. It is mainly composed of silicon dioxide, an ionic compost of aluminum, ferric, and calcium oxides.
After understanding the classification of the pollutants molecules explained by David, we can talk about properties. Typically, polar molecules are attracted to electrically charged objects, they are more difficult to separate than non-polar bonds, and thus they will have lower vapor pressure, which causes them to have higher melting and boiling points. Finally, due to the solubility rule that alike dissolves alike, they are soluble in water, which is a polar molecule. On the opposite side, non-polar molecules have no reaction to electrostatically charged molecules, they are easier to separate and subsequently have higher vapor pressure, and they end in lower melting and boiling points. And contrary to polar molecules, they are not soluble in water, but in benzene instead, which is non-polar. Finally, the strongest intermolecular force, ionic bonds, held by electrostatic force, they tend to have considerably higher melting and boiling points, and they are good conductors of electricity when in water due to the ion dipole force or when in molten state.
These molecules can be classified according to polarity, bond type, and furthermore into their kinds of molecular interactions with each other. As shown, two groups arise. Molecules would only strongly interact with one another inside the group. These groups correlate to the molecules being polar or nonpolar, because it defines the range of intermolecular forces a molecule can exhibit.
Now that we know the interactions between these pollutants, we can talk about the damage they do to the environment and the organisms. First off, nitrogen dioxide and sulfur dioxide cause respiratory diseases and permanent lung damage. They are also responsible for ground-level ozone. When in contact with water, acid rain or nitric acid and sulfuric acid eliminate nutrients from the soil. Then we have fly ash, which can cause the development of cancer, respiratory disease, and damage to the nervous system. It's another cause for contamination of the subsoil and the water below it. Then we have chloromethane, which is also carcinogenic. It damages the central nervous system and destroys the ozone layer. Next is soot, which is another cause for cancer, respiratory disease, and cardiovascular dysfunction. It also aggravates the change in climate patterns and global warming. Then we have carbon dioxide, which in extreme cases it might produce coma, asphyxia, and convulsions or even death, and it's one of the main greenhouse gases and one of the responsible for global warming. Finally, we have methane, which is another greenhouse gas that produces ozone in ground level. It can damage airways, increases chances of stroke, premature birth, and cardiovascular problems.
But now, what are the existing technologies to help reduce these pollutants? For instance, in Puebla, there is an artificial tree with the efficiency of 368 real trees. This means that it can provide oxygen for 2,555 people. Yet, the price of the device is of $50,000 plus, if needed, further budget addressed to repairs and maintenance. It also can't be home to a lot of living organisms such as birds and squirrels, etc. And this means it won't contribute to a rise in biodiversity. Now, as for the stove, stoves are great to lower the amount of toxic gases we breathe that will suffocate us. Yet, not everyone can afford a stove. Therefore, this benefit isn't for a wide range of people. As for the air suction pods, they can be installed in cities and purify up to 99% of the area after testing, yet it depends on the government's budget and initiative towards climate change or air pollution. Now, the solution that we propose is a composite liquid. The way it works is basically that it's gonna capture air coming from the atmosphere and pass it through the composite liquid. When it is in contact with the composite liquid, the pollutants will dissolve because of the solubility rule. Polar substances will dissolve with polar substances and non-polar substances will dissolve with pentane. This means that then the air coming out will not be with pollutants. And one of its pros is that water and pentane are really common materials and they are economic. Fast applications are due to the low complexity of the systems and it won't occupy as much space as, for example, the artificial tree. It doesn't have narrow range of customers, and some downsides are that it must be done in a closed space. If not, the clean air will get mixed with the pollutant one, yet it will still make air quality significantly better in that area, like the air suction pods, meaning that when someone goes out the room or building, they can still be exposed to these pollutants.
So it's also very important to know from where these compounds come from. So to start, sulfur dioxide and nitrogen dioxide comes mostly from the burning of fossil fuels. For example, coal, oil, gas, and especially the fuel that is used in cars. Carbon dioxide comes mostly from animals, from the process that they exhale this carbon dioxide and they exhale it as a waste product. Also from human activities, for example, energy production, burning of coal, oil, gas, etc. Methane is emitted from a variety of human influence activities and also natural resources. Chloromethane comes from a chemical reaction that occurs in the ocean, and also when materials like grass and wood are burned. Nitric acid can be found in nature by combining water with nitrogen dioxide, or it also can be manufactured. Sulfuric acid comes from sulfur. Water can be found in oceans, rivers, lakes. Silicon dioxide is found in nature, and aluminum oxide comes from the bauxite, which is the main aluminum ore. So what most of these have in common is that they come from human activities. So us, humans, are responsible of the production of these pollutants. Us, humans, we are the problem, and we need to stop this problem from developing any further. That's why with classes and courses like this, we can gather the knowledge that we need to develop solutions, like our proposal, or composite liquid made with water and pentane. We believe that with this composite, we're going to be able to make the world a better place. So we need to keep learning, to make new changes, and to work for a better future.
Policies should be taken to lower pollutant emissions from combustion and waste disposal. This by driving for low-emission technologies as well as opting for renewables and carbon-neutral power. All in all, residual compost should be reintegrated into the industry to prevent contamination and reduce remediation efforts. This promotes sustainability and transforms waste into valuable resources.
Due to the pollution that is produced daily by the human and its activities, it is important to reduce these emissions and eradicate the existing ones. The composite of water and pentane seem to me like an easy and reliable solution that can be used even at home. I know there are air purifiers made with water, which leads me to think that this solution can be applied similarly.
So, in conclusion, by advertising our solution in social media, TV, etc., it will make it possible to escalate globally. So, institutions such as the United Nations Environmental Program can take this into consideration when signing future resolution papers that will help humankind achieve the SDGs.